All right, so starting on beam systems, we're essentially going to insert a beam system right here in this area. It's going to tag the beams, and we're going to see them run across here. Now, we're going to deviate a little bit from the book, so I'm going to go a little bit slower than I typically would. I'm going to exit out of this. When I click on beam system, keep your eyes on the right-hand side of the screen. You'll see that for a brief minute there, the buttons that the book is asking you to press have already been pressed. So I'm going to do this again so everybody can see it. I'm going to exit out of sketch mode. I'm going to hit beam. And you saw that the automatic beam system and the tag on placement were both selected. So basically what that means is when we create a boundary, it's going to insert beams in there and it's going to tag them automatically. That's all of the first couple steps in the book are asking you to do. So now what we're going to do is come in here and draw a boundary in here. And we can do that a number of different ways. I'm going to do it by picking lines. I want that line, that line, that line, and this line. And just like our other boundaries, I'm going to clean that up. And you want to pay attention to this line, this double line right here. That basically shows you the direction of the beams. If I want them to run in this direction, then I want those two lines this way. If I wanted them to run this direction, then I would want to come up here and change the beam direction. But the beam direction is proper for what we want to do. Next thing the book asks you to do is item 5, change the layout rule. So we haven't dealt with layout rules yet, but you're going to deal with them in beam systems and you're going to deal with them in storefront systems. So we'll go in here and we're going to say that the layout rule is not fixed distance, but it's maximum spacing. And we're going to say that the maximum spacing of our structural member should be 4 feet. Now what this is going to do is it's going to put in as many beams as required to fill in that boundary with a 4-foot maximum spacing. All right. I'm going to hit apply, and we're going to hit enter. And what that's done is it has placed these beams in place for us. Not enter. Check the. I'm sorry, not enter. You're gonna edit or complete the sketch mode with the green check mark. So what you'll see is that we have these structural members that are 6 by 6 by 5/8 of an inch, and we assume that this is less than 4 feet, this is less than 4 feet, this is less than 4 feet, and this is less than 4 feet. Just to double check that, I'm going to go to annotate, and I'm going to take some dimensions. You see this is 3 foot 10 1/4. And it's all equally spaced. Any questions about adding that beam system? Yeah, this works really well for big open spaces where you have a lot of the same structural member over and over and over. You can place those very quickly. And it's important if you're working with a bunch of consultants and they're not modeling, like say your structural engineer is not using Revit for whatever reason, you can take their drawings and interpret them very quickly and model those structural elements. I can't tell you how often a beam or a column or a joist conflicts with HVAC ducting or a ceiling, or I was just walking through a school the other day and the diagonal bracing is a mess all throughout the school. There's a bunch of places where it's exposed, where it looks like it was an afterthought, probably because it was an afterthought. If you go ahead and model it, then you got to deal with it, and that moves your design forward. All right. So that's really kind of it for adding a system. What you'll notice is there's a couple different ways to select this. If I roll over the edge, I'm selecting the actual system. And I can remove that, or I can edit the boundary of that system. For example, I'm just going to go in. I'm deviating from the book here a little bit, but I want to show you a few things you can do with this. I'm going to edit the boundary. And I'm going to take this, and I'm just going to space it out like that. And I'm going to bring these two things together. And if I finish this, Oh, well, it should have placed my beams. It didn't place the beams because it sees this as a structural element. But you can see how the grid changed that those beams are placed on. So just like we put columns on a grid earlier, we could now go in here with the beam tool and actually place those beams. I'm pretty sure if I took well, we won't deviate from the book there in that regard. So to take this back to where it was before, I could simply come back in here and edit the boundary. And this is you should be very familiar with. Do you agree? This is something you've done a lot of. And I told you as you were learning about sketch mode that you would use that a lot for a variety of different tools. But sketch mode is a way for us to input that information. And then you can actually select the individual beams. What you're going to notice about the individual beams is by default they're pinned. So if I wanted to modify this beam, say for example I want to delete this particular beam, it's going to tell me the object's pinned, you can't delete it. You would just simply have to click on here where it wasn't pinned, and then you could delete it if you wanted. I'm not recommending that you do, but from time to time you may need to delete this beam or change this one particular beam to a different type. For example, we need to change this beam to a W12 by 26 when one beam might differ in size than the rest of the beams in the system. And that happens from time to time depending on how the structural engineer is using that particular structural element. All right, so to walk through the process again, I'm going to do the beams on this side. The book doesn't ask you to do that, and you could simply mirror them, but I want to walk through the process one more time. So Structures tab, Beam System. I'm going to do this one with a rectangle. No, pick lines is probably. Pick structural element and then pick lines. Make sure to clean your corners up. We're going to take maximum spacing. On this one I'm going to do it at 3 foot just to show you that it will add extra units. And we're going to hit OK. Now what happened? Yeah, I didn't pay attention to my beam direction. And by default, the first line you draw or the first line you pick is going to be the direction of your beam. So if I wanted to fix that, I could come in here, edit the boundary of the system. Well, maybe. Edit boundary. And I'm going to take the beam direction and say, no. There we go. Now I've moved my beam direction. If I hit finish, it will rotate all those beams. So you could do layout very quickly and say, hey, no, this beam section doesn't work. You could say, hey, what if I come in here and edit this system and change the spacing on that system to 5 foot? What would that do? And hit apply. And you'll see that it would reduce the number of structural members. So this is a very good tool, not just to document and model the actual structural elements, but to really kind of work with them and understand where they hit in your building. Any questions about that? It's deceptively simple. It's a very, very powerful tool. All right, so the question was, how do I change the beam direction? You select the beam system, edit the boundary, and then you come in here to beam direction and select the way you want. And wherever these two lines are is the direction those beams are going to run. So I'm going to cancel that edit because I really don't want to do that. And there we go. So that, again, a deceptively simple tool. So it's very easy to create quick systems of beams and add a lot of detail to your models very, very quickly. All right, so the next thing we're going to tackle is adding bracing. And in this one, we're going to add a thin rod to the top of the canopy. It would be nice to add a rod to the top of the canopy at an angle. You can accomplish this by using the brace command. To do so, you'll need to load the rod. considered a family in Revit into the model. To use the brace command, first add the rod family to your model. Item 1, go to the Insert tab on the ribbon. And you're going to see this little button here called Load Family. All right, we want to browse to Structural, Framing, Structural Framing, and let's see, Still, and the file Round Bar. Okay. Great, so that family's loaded now. We can use it. Item 4, go to the north elevation in the project browser. Notice the grid lines A and F are visible in this view. So if we use project browser and we go to elevations, north, double click on that. So A is there and F is there. And we should have a little canopy out here. It's kind of hard to see, but it's there, right? In the Properties panel for North Elevation, change the detail level to Fine and Visual Style to Shaded. So we'll come over here, we'll make it Fine and Visual Style Shaded. Now it's way easier to see, right? There's our canopy. And that's that big W12 that we put in there inadvertently, so I'm going to change that back to a 6 by 6 by 5/8. Alright, so that's what yours should look like. And basically, we're going to add a rod from here up. On the Structures panel of the Structures tab, click the Brace button as shown in Figure 8.44. So go to Structures, we're going to hit Brace. Revit displays a dialog asking you to specify a work plane. In the name drop-down list, select Grid 1 as shown in Figure 8.45. And you guys should be familiar with this. We actually used these work planes earlier to do stuff. And what you'll notice is every grid has a work plane associated with it. So that makes it easy. So now we're constrained two-dimensionally in Grid 1. And you'll notice in our properties we now see round bar 1 inch because we loaded the round bar family. Item 9, verify the round bar 1 inch is the current framing member in the type selector. Draw a diagonal line as shown in Figure 8.46. I'll let you eyeball this one, or you can make it, the top offset a specific increment. Alright, so we're basically going to come in here. We know we want it to go from there. And you can put this really at any dimension you want. I'm going to leave it at like 25 degrees. Seems to be nice. And what do we have? We actually have a model of a bar now, right? And don't worry about this forests and things that you see in there. That's for structural analysis. But it's nice that you were able to quickly model that bar for your brace. Alright. Next action. Adding the rod at an angle. Go to Level 2 Floor Plan. We're going to zoom in over here. And you can see that rod is right there. On the Quick Access toolbar, click the Section button. That's this little icon right here. Or you could have gone to View and gone to Section. We'll use the Quick Access toolbar. Place the section along column F in Figure 8.47. Okay. I'm going to flip this because it's actually showing the section in looking in that direction. Open the section. Rename the section Framing at North Canopy Elevation. Oh, no, just Framing at North Canopy. Alright, so we'll come down in here. Instead of Section 1, we want to hit Rename. framing, and north, east, canopy. Okay. Change the detail level to fine and the visual side style to shaded. Detail fine, visual style shaded. On the let's see. Nope, sorry. Yeah, on the structures panel, the structures tab, click the brace button. Choose grid F. Draw a diagonal rod between the points in figure 8.48 and press escape. Now this seems like a really strange thing to do since there's a column right under where these rods connect. So really this is just aesthetics. They're not structurally doing anything. But there are a lot of times you're going to have a small canopy like this where you need to add rods. If you look at the front of the building here at Western, when you walk in, it has a canopy that has tension rods. So this would be the way that you would actually model those rods. So tonight when you're leaving class, take a look at that. And those of you in the internet section of the class, take a look at that next time you're walking inside the Revit, or the architecture building here. All right. Now we're going to go look at a 3D view and see what it looks like. Remove my properties. You can see I have my my two rods, one on either side.
What was the angle of your rod?
I just use 25 degrees, but it's not really specific. It can be any angle that you like architecturally. Okay, now we're going to move into foundation systems, essentially stuff that happens below grade or below the ground. Item 1, go to level 1 floor plan. Looks something like this. Item 2, click the wall structural button on the structures tab. This is the same wall command as we've been using, just happens to be on the structures tab. In the type selector, in the properties dialog, select generic 8-inch masonry. We will do that. Generic 8-inch masonry. Click the edit type button. Click the duplicate button. Why are we clicking the duplicate button? Yeah, so that we're creating a new type. So yeah, we don't want to, all the generic 8-inch masonry walls, we don't want to have the properties of of what we're creating right now. So we're going to call this 18-inch concrete, which is a pretty descriptive term. One would assume that this wall would be 18 inches thick and it would be made out of concrete. Okay. Click OK. Click the edit in the structures wall row, go to structure, and we're going to change the material to cast in place gray concrete. You should be very familiar with this at this point, and should start to see that the assembly of a wall and the assembly of the slab are not all that different. We're going to change the thickness from 7 5/8 to 1 foot 6 inches. And we're going to hit OK. And hit OK again. That's going to take us out. And now we're working with a wall that's 18 inches thick and has got material properties of concrete. You're about to place a wall under this level. This view is currently set not to show anything below this level, forcing you to alter the view range. To modify the view range, follow these steps. Item 1, press escape twice and then scroll down to the view range. Alright, we're going to press escape twice to get out of the wall command. Then we're going to scroll down to view range and hit edit. For the primary range, set the bottom offset to -1 foot. -1. For the view depth, set the offset to -1 foot. So basically, I've just extended the view down 1 foot. Click OK. Start the structural wall command again. So structures, wall. On the draw panel, click the Pick Lines button icon. That's this one we should be very familiar with at this point also. Item 7. On the foundation, walls are placed top down, so depth rather than height appears on the options bar. So see here it says depth. We could change it to height, but we're going to leave it at depth. Make sure the depth is set to top of footing, or T.O.footing, commonly referred to as top of footing, and justification is set to wall center line. So we'll go top of footing, wall center line. Great. So it's going to start drawing at level 1, essentially, and it's going to draw the wall down, which is exactly the opposite of a regular wall, which starts drawing at level 1 and draws the wall up. Pick the center line of the exterior wall as shown in figure 8.52. Okay. So it looks like nothing happened. Would you agree? So I'm going to deviate from the book here just a little bit, and I'm going to draw a quick camera to show you that something actually happened. I actually want to draw a camera. I don't want to use the default view. Camera. Click and drag that out. And you can see now we have this massive wall. Do we see construction with foundation walls this deep here in Las Vegas?
No.
Just because we don't build it this way in Las Vegas doesn't mean buildings don't get built like this. A lot of times buildings will be built with very deep foundation walls. Why is that? Well, it's primarily because of frost line, right? They're trying to get the foundation wall down below where the ground will typically freeze. Why is that important? What happens when water freezes?
It expands.
It expands, right? So what happens when ground that has a bunch of water in it freezes?
Displaces.
It expands. And if your footing is above that, what happens to your building? It will rise in some places and not other places. Buildings don't like that. It's called differential movement, and it causes cracks and structural problems. So just because this looks absurd, if you're used to how stuff is built in Las Vegas, believe me, there are buildings, a lot of places that are built this way. Really, basements have come out of this idea. If I got to go 10 foot down for a foundation wall, I might as well make a room or make a basement out of it. Anybody try to dig here in Las Vegas?
Oh, God.
Yeah, it's kind of hard soil, right? Not a lot of basements here in Las Vegas. All right. So where were we here in the book? We're going to go around and pick the rest of the walls until our model looks like the figure 8.53, which basically just has all the exterior walls. With this wall. So I'm going to close out of this view that I created, and I'm going to go back to structures, wall. I'm going to pick lines, and I'm going to hover over the center line, and I'm going to hit tab. That looks good to me. And I got an error. What error did I get? Highlighted walls overlap. One of them may be ignored. What this means is these two walls are completely inside themselves. So to fix that, I'm going to go back to my 3D view that I just created, and I'm going to delete one of those walls. And get into the habit, if you have overlapping stuff, delete it right away. Otherwise, when you do a takeoff or down the line you're trying to do something, you just don't know why it's not working or there's a weird line. It could be that you have 2, 3, 4, 5, 6 walls on top of each other that you haven't noticed. So clean modeling would dictate that we take care of that right away. So I'm going to move around the rest of the building, same way. Structures, wall, pick. And I can either do it by hitting tab, or I can simply come in and grab those center lines. Grab that center line. Grab that center line. Yeah, I think it's all the exterior walls. Figure 8.53, we'll go to the default 3D view and you'll see that my figure looks kind of like their figure, except theirs is really from this side over here. You can kind of see now we have a foundation wall at the perimeter of the building. Except we missed these walls. So I can actually draw that in 3D on the fly here. But you want to be careful about that because the line that I selected was the outside line of the wall. So what looked simple and easy to do in 3D actually did not create the effect that I wanted. So I'll clear out of this and I'll go fix that over here. Go back to my default 3D view, and there we go. This looks correct now. Great. Figure 8.53. Now you can travel into the ground and check out how your walls are joining. Some cleanup will be involved. It looks like I missed the elevator shaft, so let's go ahead and put those elevator shaft walls in. And that's real simple. We'll just go through that process one more time. Wall, pick line. Uh-oh. Oh, no, that's because the elevator shaft walls are already in. My bad. All right, so let's go into 3D mode. Let's look at it from the bottom. And you can see I have that, so I'm just going to hit delete on that wall. So structural walls are not any different than other walls. You can see that we got some cleanup issues here that we need to work on. All right. In the project browser, double click on the top of footing floor plan, TO footing floor plan. We're going to come in here, and you can see we have some issues with how walls are cleaning up. Zoom into the east wing area where the north elevator meets the foundation wall. However, the walls are funky as shown. Select the left masonry shaft wall. So that's this wall. Drag the in blue grip of the wall so that it abuts the foundation wall. Looks like this one's already been cleaned up. No, no, oh, no, no. I shouldn't have done that. Okay. Recording again. Alright, so sorry for that. I got a little off track. But basically, we're going to grab this wall. You're going to take this blue line, or blue grip, and you're going to drag it back. And that will clean up the corner of this wall so that it works properly. The masonry wall to the right needs to be joined to the foundation wall. To do this, click the Join Geometry button on the Modify tab. So if we go to Modify, Join. And then we click these two things. And it's going to clean up that wall joint. Alright. Moving to the west wing, you'll need to fix one wall. You'll use the split command as follows. Zoom into the area shown in figure 8.56. That's this area over here. And you've used the split command here before, above grade. On the Modify tab, click the Split Elements button. That's this little button right here. Pick the points marked 1 and 2 and press Escape twice. I'm trying to be pretty precise about this. And that's made this its own separate element. And I can simply grab that and delete it if I need to. Or I can change the properties of it. So the next element actually goes back to the question that you had about, do we add footings to this? And yes, we're going to add footings. Revit treats them differently than the walls. Adding structural footings. If you're going as far as placing the structural foundation walls, you might as well continue and place footings under them. Before you begin adding structural footings to the plan, you need to acknowledge that by default, this view isn't set up to see objects that are physically below its level. To correct this, you must alter the view range of the specific plan following these steps. Make sure you're still in the top of footing plan. And we are, and we know that because it says it right here. In the Properties dialog, go to the View Range row. And click Edit. Set the primary range bottom to Unlimited. Set the view depth to Unlimited. So basically this is going to cut at 2 foot above the top of footing elevation, and it's going to shoot down for infinity. It's going to see everything below it for infinity. Which literally the only thing below it should be the foundation and dirt, if we've done our job properly. Okay, we're going to hit OK. On the Foundation panel, the Structure tab, click the Wall button is shown in figure 8.58. Don't confuse this with the structural wall. You got to go to Foundation and go to Wall Foundation. Don't come over here and click this button. It won't get you what you need. You need to come here to Wall Foundation. In the Properties dialog, click Edit Type. And what do we almost always do when we click Edit Type? Click the Duplicate button and rename it something that makes sense. We're going to call this bearing footing 30 inches by 12. We're going to change the depth or the width of that footing to 2 foot 6 inches or 30 inches. Click OK, and we're back in the model. So we should be drawing something that's 30 inches wide and 12 inches deep. That makes sense? Start picking the walls. The footing will be centered under each wall that you pick. All right. You can see that it starts to add 2 more lines as we pick these walls.
Are we supposed to clean up that other elevator shaft?
You could have. It's not critical at this point. Alright, so let's go into the 3D view. And what you're going to see is now we have a footing associated with that wall. And it's a parametric footing, so if we selected it, we could change the size of that relatively easily to 36 or 30 or whatever width we actually wanted to change it to. So my mistake here, I shouldn't have added it to the elevator shafts. I'm going to go ahead and delete the elevator shafts because we're going to add a structural slab actually at the bottom of the elevator shaft. But like with most things in Revit, it's very easy to make a modification. We can clean up this side of the elevator wall also. There we go. That makes that footing nice and nice. We'll go ahead and join this as well. And really, the key to Revit is repetition, using the commands again and again and again. So don't feel bad if you have to undo something or redo it. That's just part of the territory. All right, structural slabs. Structural slabs are basically thick floors. The one you're about to use is a solid concrete floor 12 inches thick. Of course, Revit doesn't have something this thick built in the library, so you'll take this opportunity to make one. Here are the steps. Go to the top of footing floor plan. We happen to be in the top of footing floor plan. Zoom into the elevator area. On the foundation panel of the structures tab, click slab, structural foundation slab. So here, slab, structural foundation slab. And that's going to take us into sketch mode. But right now, all we have for structural foundation is 6 inches thick. Is that going to work for our needs? No. So how are we going to fix it? We're going to edit the type. We're going to duplicate. We're going to name this 12-inch foundation slab. We're going to edit the structure. We're going to take this and make it 12 inches. Hit OK. Hit OK again. And now we're going to draw a boundary, essentially around the elevator, but we're going to offset it by 1 foot. So we're going to pick wall. We're going to offset 1 foot. And I'll fix that one here in a second. I'm going to actually pick a line here so I get the outside of that footing there. Then I'm going to clean up this boundary. So, just like a slab, this boundary should be filled in with the properties that I select. And there we go. We've got a nice big footing underneath our elevator. Now I could redraw this on the other side, or I could mirror it. I'm going to mirror it. There you go. Alright, so that should give us, let's go to a 3D view. Well, that's interesting. Why is it looking like that?
Did the other wall get lost in the foundation that's around the perimeter of the building?
Nope.
I have no idea.
Well, later here in the book, it's going to tell us how to fix that, but anybody got an idea of how it got there? Remember when we modeled the shaft? Several chapters ago, we modeled a vertical shaft. Well, that vertical shaft actually goes right through the bottom of our floor right now. So we're going to have to modify that shaft. So very simple to model the shaft or correct the shaft. We're going to go to 3D view. If your slab looks like figure 8.65, which ours does, select the elevator shaft opening. All right, and it might be kind of difficult for us to select here. So if you're having a tough time selecting it, as I am, we can use a filter, right? I can come across all this stuff and go to filter, and it says I don't have it, so I must not have selected enough. Let's try that. Filter, shaft opening. So we're going to check none, and we're going to check shaft openings. Now I have my shaft opening, and I can edit that. It says my base offset is -1 foot below top of footing. Do I want it -1 foot below top of footing? No, I probably want it at 0. I'll change that to 0. And what you'll see here is now my slabs are there. My slabs were always there. The shaft opening was creating a void within the slab. Does that make sense?
Oh, okay.
That's all it was. Alright, so the next portion of this is pier and spread footings. So item 1, we're going to return to the top of footing plan. I can do that just by closing out this view. It will return me to the last view I was at. And we know that we're in top of footing by looking right here. On the Structures panel of the Structures tab, click the Column button. So a pier really is kind of like a column. So just like we had a structural wall and then we had a foundation, we need to add piers and then isolated footings below them. We're going to click on column here. On the Modify Place Structural Column tab, click the Load Family button. Okay. Browse to Structural Columns Concrete. Make sure it's Structural Columns. Concrete. And pick the file called concretesquarecolumn.raf. Okay. Click Open. In the type selector, select 24 by 24. Begin placing columns at the grid intersections. Uh-oh. We have grid intersections here. That's pretty easy, right? So we could say at grids, and we could select a bunch of grids. And what happened? It placed them. Do we know there's columns at all those locations? There isn't. We know there's not a column here. Here. We know that the columns here are in different places, but that's a good way to get started. Move the piers under the columns that you moved before. Alright, so what I'm going to do, just for well, we're supposed to be doing all this in level 1, but let me go to level 1. Yeah, I just screwed up royally here. So let's go back to top of footing. I missed one critical step. Let's delete these because they're starting at the footing and going down, right? Let's go back to level 1. And now, let's go to column. Square 24 by 24, great. And I'm going to say at columns instead of intersections, so that when I select these, maybe finish. No columns were added. Well, I tried to select columns. Alright, add grids. Alright. There's a column right there. That's bad. Bad news. I don't know why there's still a column in the middle of their model. I'm going to go here and I'm going to turn the underlay of the footing plan on so I can see where it placed the columns. Does that make sense? Except I need to hit escape a couple times, so I'm in here. And underlay, right now I have none, but if I go to top of footing, underlay, and hit apply,
So you need to be unbounded?
no, for some reason it's just being difficult. Alright, so I'm going to try one other thing to make the visibility where I can actually see what I'm doing. I'm going to take the floor, and I'm going to temporarily hide the floor by hiding this element. And I'm going to go back to underlay. It looks like I didn't put any columns in even though I thought I did. So make sure that I'm in floor plan. I am. Okay, so I thought I added some columns, but I did not. Let's try this one more time. Columns, add grid. Oh, I might have. Let's see.
Did you have to finish?
Let's go back to our columns. Sorry for any confusion. It's good to watch you guys watch me work through an issue. They got a depth of 9 foot. If I look at the properties, moves with grids, moves with, okay. One would think that this should. Okay, sure. Now, when I place them individually, it's going to work. So you just want to go ahead and place your columns. And in this case, these columns here are really working to transfer this load all the way down to the ground. So what we're going to do is put an isolated footing on these columns that's larger than the column to spread that weight out across the ground. So we'll just focus on these 4 here. Now you'll add the spread footings under the piers. This process is almost identical to the previous one. Go back to the top of the footing floor plans. So let's go back to top of footing, and now we should see. Okay, I'm thoroughly confused now. Let me go into 3D and see where our why I'm not seeing them. Okay, they're there, right? So top of footing. I'm not seeing them. What could be causing me not to see them?
The view range.
All right, let's look at view range. View range. Oh, it says it's unlimited.
Well, how about?
Okay, so sometimes you can't see stuff because of visibility graphics. So I'm going to type VG, and we haven't really gone over this. But this is all the different stuff. And you can see that I have structural columns.
That's B.
And it says I should be able to see them. VG for visibility graphics. All right, so that's not the problem. I should have some structural columns there. Do you agree? All right, so let's cut a section. Why don't I see my structural columns?
They're not reaching all the way down. Wait, but isn't the view range 2 feet above the top of footing?
No,
So shouldn't you be able to see it anyway?
I don't know. One would think. Let's go back to our view range.
What if you change it to 4 feet above?
Well, let's look. View range. Top of the foot should be 2 foot, but my cut plane is only 1 foot. So I need to change my cut plane, right? So if I change this to 2 foot, also, What shows up?
Bingo.
All right, so just because you don't see something does not mean it does not exist. Just means that your view, for whatever reason, can't see it. So you just saw me work through a number of ways to figure that problem out. The reality is those columns probably need to be deeper. Would you agree? So I'm going to delete that section because I'm not using it. It'll tell me section 1 will be deleted, no big deal. Alright. So back to adding some isolated footings. No structural foundations are loaded into the project. So we need to go back to the top of footing. On the foundations panel, the structures tab, select isolated foundation. That's this button here. We haven't used it yet. When we click that, it's going to tell us no structural families are loaded. So yes, we want to load one. Browse the structural foundations. And why do you think we don't just put a small column underneath this? Why do we go load a foundation?
Because you want to spread the weight out over more than just 16 by 15.
No, it's a concrete, right? If I put a 30-inch by 30-inch column underneath my 24 by 24 column, it would still be concrete. It would still be the same size. The reason I don't do that is Revit deals with things by classification. So if it's a foundation, I want it to act like a foundation. I want to analyze it as a foundation later in the process. I make it a foundation. Does that make sense? And we're going to go to footing rectangular and open that. First thing we're going to do is edit the type because we don't need a 72 by 48 by 18 inch footing. And we are going to duplicate that and name it 36 by 36 by 12. And you might be going, wow, that seems like a really large foundation. The default, I can guarantee you it's not that big of a foundation. We have foundations that large all the time. Alright, we're going to take the foundation thickness and make that 1 foot. The foundation thickness here and make it 3 foot. Or width rather, and length 3 foot, 3 foot. We're going to hit OK. And we're going to click on those columns. And it's going to add a spread footing. And it added a double line. We'll go to 3D to show you what that looks like. Uh-oh, what happened?
Kept floating.
Yes, is our structural engineer going to be very happy with us?
He's like pissed off.
So, we need to take this and we need to tell it, hey, go down to 10 feet. And it will work. And then to do the other three, I'm going to show you the match attributes command. I think we maybe used it before, but if I type in MA, next to my cursor I get a little paintbrush. You can see it's white. When I click on this, it becomes black. That means it's loaded. Oh. And then when I come over here, no, Revit just doesn't want to play nice. Alright, so we'll do it another way. And we'll just hold control and select all three of these and go back and change it to negative 10 feet. So when something doesn't work in Revit, what should you do?
Start adjusting.
Beat your head against the wall and try to do it over and over and over and over?
Do something different.
No, you have a lot of different tools at your disposal, a lot of different ways to get to the desired result. Alright. Oh. Using structural views, I'm not really going to cover that. You can go over those 3 or 4 steps if you like. We start setting up sheets, we'll go over views again, but if you recall, we went over views early in the semester. So that's going to conclude Chapter 8 for us. And the next thing we'll be working on is Chapter 9. But in the interim, you should really start working on your case study project, making sure that you have it modeled really before the beginning of April, all the way up through Chapter 8, the things we've covered up through Chapter 8. So that gives you a couple weeks to really focus on that. And then obviously we're going to continue to move forward in the book. So welcome back from spring break, and we're in a mad dash to the finish of the semester now. Thanks.